Just a short disclaimer before I start this video that I had actually recorded this video months before uploading it last October. So eventually what's happening here is that because I actually recorded it in a very long time ago, the recording technique of this video was a bit different compared to what I do nowadays. So when it comes to that, you'll hear a lot of background noise in some places where in some cases I actually try to overlay those background noises or whatever recording I did with a dubbing later on. But yeah, this is one of the issues that I had to go through. So I apologize in advance and I tried to remove as much as I could. Otherwise, if there were any sort of unavoidable stuff that you notice, then you have to face it. So yeah. Another thing I've done to avoid the background noises is to actually lower the sound of the recording of the video that I've already done. So you may hear my voice in a bit of a less volume afterwards. So I would advise you to increase your volume in that case. Otherwise, if you're still facing any issues, again, I apologize. So yeah. Anyways, let's just start with the video. I'm going to start off with this one, this paper right here. Um, I'm going to basically look at this one. Question 1, x plus 3a is greater than x2 into x minus 2a. Now the thing is that you can solve this in two ways. One of them is that you can basically either draw a graph or you can whole square both sides and solve the inequalities, get some values and check if they meet within the range. I mean, you have to cross check here. So for example, in method 1, if I show, I'm going to try showing you both methods. This is method 1 where I square both sides. So I have x plus 3a whole square greater than 2x minus 4a whole square. So I have x square plus 6ax plus 9a square greater than 4x square minus 16ax plus 16a square. So I can take these towards the left side so that I can have a positive coefficient of x square. So I have 4x square minus 16ax plus 16a square less than, because we take this to the other side, it's the exact same thing as this, minus 3 greater than 2, sorry, less than 2. Take this to the other side, we have 2 greater than minus 3 obviously. So that's what I'm doing here. This is less than x square plus 6ax plus 9a square. So now we have 3x square minus 22ax plus 7a square. Now keep in mind that it is not necessary that we can use quadratic stuff here. We can basically break it down and factorize it. How? We have x square, we have a square, and here in the middle we have ax, right? So I can easily do middle term breakdown here. So it's going to be 3x square minus 21ax minus ax plus 7a square less than 0. So we have 3x x minus 7a minus a x minus 7a less than 0. We have 3x minus a x minus 7a less than 0. Now we can basically take things common. Here we can now basically draw this in a graph. A is a positive constant, so it means that it will be, let's say, if I put this equals to 0, then I'm going to have x equals to a by 3. Critical values are x equals to a by 3 and 7a. So if I draw this on my graph, a by 3 means here and 7a means here. So basically I have a by 3 less than x less than 7a. Now this is basically the only thing. If there were two values, let's say if it was greater than 0, alright, if this was greater than 0, then you would have x less than a by 3 and x greater than 7a. So let's say you have to take here, let's say 8a, using a value larger than 7a, which is let's say 8a, and a value less than a by 3, which is let's say a by 4, or anything less than that, so that we can get our desired value. Alright, I mean, if one of these, I mean, basically, if this is satisfied, then I can easily say that this is okay, and if this is satisfied, then we can say this okay. So we can include both of these things. If this, let's say this does not satisfy, we have to declude this one, and we can only include this one, things like that. Alright, this is how you have to work with this one. But on the other hand, we have method 2, which is a graphical method. So you have to draw a pretty accurate graph. Now 3a is basically, it is kind of like y equals to x plus 3a, and y equals to twice of x minus 2a. So basically x plus 3a goes like this. Basically 3a is basically larger than this one, so 3a goes here, y equals to x plus 3a. So basically I think the way this works is that first of all we need to draw the graph without looking at the modulus, and then you deal with the modulus. So without the modulus we have x plus 3a. So 3a is, let's say, here, and minus 2a is, let's say, here. Alright, for the 3a graph I need to just draw it like this. Okay, so I'm just going to draw this a bit lighter so that we can distinguish lighter, but my actual curve is going to only go like this.
Alright, it's going to go from here to here. I'm going to make this a bit darker in color. Okay, a bit darker. Duplicate that, and we are going to have eventually a curve that goes like this. It may or may not be symmetric enough, but I guess I can try it this way. And then I have x minus 2a, which means that my curve is going to have the exact same gradient as that, but it's going to go in this direction. Okay. So it's the exact same gradient as that, and then my second curve is going to go like this. I'm going to duplicate it, make this shorter, and then flip this up. The curve is technically going to be exactly the same as that, but then I have to basically do these things like this. My final curve is going to have a much higher gradient like this. So my only thing that I want to care are between this dark blue and dark red graph.
If you can, I mean, I don't have the option for dashed lines, so I cannot show you the dashed situation, but I think you get it. Basically now it says this curve will have to be greater than that, which is only possible. Yeah, actually I drew it a bit wrong. It should, I can actually draw this a bit more towards here, and then a bit more towards here, then it would make more sense. But basically it says that x plus 3a, the value of x plus 3a, on any value of x, the value of this one, or value of y, has to be greater than the one at the bottom. So it means that I'm talking about this region. I'm talking about this tiny region there. And obviously if you solve these two together using the equation stuff, we will get two values. One of them turns out to be one of them turns out to be a by 3, and the other one turns out to be 7a. So it actually still works. There is another one way we can actually solve this equation. So our value is going to be a by 3 less than x less than 7. These are the two ways you can solve this equation.